All right, good morning, everyone. The first thing that I need you guys to do is I need you guys go into Schoology and into the MCA folder for our notes. I need you to download all 6 of these lessons so that way as we're taking notes over the next 6 days and reviewing for the MCA, that you already have these downloaded, because again, you will not have Wi-Fi access on most days due to the MCA testing. And then once you have all 6 of them downloaded, make sure you leave this one open. That's the lesson that we're going to be doing today. So once everyone has it, all 6 of them downloaded, go ahead and press play and then continue on with the lesson. So today we're going to just spend some time looking at 4 different things that you guys have learned. Every day will be something different, but our goal for today is for us to take a look at some just important vocabulary words and properties, functions, our order of operations, and then the distributive property. So the first vocabulary word that we're going to review is absolute value. For this one, hopefully you guys remember with absolute value, it makes the number positive. And these vocab words will also help you as you guys are working on the crossword puzzle. So again, if you want to think about this one, absolute value of -3 is 3. Absolute value of 4 is 4 because it was already positive. Our next vocabulary word is opposites. Now when I think about this one, I think you guys would know that opposite in numbers, like one number is positive, it's the opposite would be the negative of it. But what I want us to think about is our opposites when we are solving equations. Like if you saw addition, what's the opposite of division? Addition. You would say subtraction. What's the opposite of multiplication? You would say division. And then again, opposite of multiplication is addition, opposite of division is multiplication. So those show some opposites. We just recently learned about if you have a number squared, that's the same thing as taking the square root of that. Those two are opposites of each other. They undo each other. Next thing is remember order of operations. PEMDAS, or if you want to think about GEMDAS, you could put a G there and think about that as your grouping symbols. But you want to do your parentheses. And then your exponents. And then multiply and divide from left to right. And then add and subtract. Oop, right, I'm running out of room there. And add and subtract from left to right. And we'll get some good practice with that today. When you guys take the MCA, my guess is those questions are going to be the no calculator types of questions. So you won't be able to type those into the calculator. Our rational numbers, we learned about these at the start of the school year. Remember, these are numbers that can be written as fractions. And this is written. And irrational are numbers that cannot be written as fractions. So hopefully that's a good review of them for you. But we have a few more for us to take a look at. Next thing I just want to review with you guys is remember that when you're thinking about your x values, another name for that is your domain. Domain and x go together. That's also another name for your input. Also remember that's the independent variable. That's the variable that you have control over. And then remember the x is always graphed along the x-axis. And then this video, just so you guys know, we'll watch this one tomorrow when I'm back. Then for your y or f of x, remember this is just as another way to write it. It's a function instead of an equation, but these two are synonyms of each other. But when you think about the y, that talks about the range of the function, the output, dependent because this value depends on something, and we graph it along the y-axis. Some properties for us to refresh our memory with. The associative property. Remember we talked about this one. Think about who you associate yourself with. It's a group of friends, and your group of friends can change. So we might have something where my first group is A plus B in parentheses equals C on the outside. But maybe who you're associating yourself with, that changes. So you're going to just group another part of the expression. But this time B plus C is grouped together. And also remember, I'm not going to write this one down, but remember this property also works for multiplication as well. So on the side there I'm going to put addition and multiplication. Commutative property. This is the one where you can add or multiply in any order. So I could do A plus B, or I could do B plus A and get the exact same answer. So again, this word works with addition and with multiplication. The distributive property, I know this was your favorite property that we learned all year long, but this was the property where you have A times the quantity of B plus C, and this is where you distribute into the parentheses using multiplication. And this is the only way that this property works. It already has the addition there and it has the multiplication. And last but not least, we have our two identities. Remember, we have an identity for addition and an identity for multiplication. Identity means that you get the exact same number back. So if I start with some number, we're going to call it A, and if I add 0 to it, we get A back. Similarly, when we multiply, if I multiply by 1, I get that A back. So that's why it's called the identity property, because you get the exact same number or variable back. All right, let's actually take a look at reviewing some things. This lesson, it talks about, do the following table or set of ordered pairs represent a function? Remember, with a function, think about that. Are the girls cheating or not? That's what we're concerned about. And that'll hopefully jog your memory. So let's take a look here at this first one. Input. The input, this is going to be our girls, and this is our boys. Let's look at our girls. Are any of the girls repeated? 1, 2, 3. Nope. None of these numbers are repeated, so this is automatically a function. So this is a yes. Let's look at our same thing with our next input-output table. Again, girls are always the input, the boys are the output. Go across. Are any girls repeated? Hopefully you're saying, uh-oh, 5 is repeated. So is this a function? No. We talked about in class, just as a refresher, and for those of you who weren't here when we learned this lesson, if the girls are cheating, not a function. Now let's look at our ordered pairs. With an ordered pairs, you could make an input-output table like we just did, but when we learned this lesson, remember we made that mapping diagram? So it's basically the two ovals. In the first oval are all your x values. And then in the second oval are your y values. And then we connect to see who's dating. 1 is dating 2, so those are connected. 2 is dating 3, those are connected. 3 is dating 4, 4 is dating 5, and 5 is dating 6. And again, we look in this bubble to see, do any of these numbers have more than one line going from them, indicating that they are cheating. In this case, none of them have more than one, so this one is a function. Let's go ahead and try this one. This one, all of my x values are the number 7. My y values are 1, 2, 3, 4, and 5. Showing the relationships. Uh-oh. Hopefully you guys are noticing 7 has a bunch of lines going from it. This indicates that the X is cheating or the girl is cheating, so this is a no. Let's continue with input-output tables. You guys have actually done input-output tables for a really long time. This is basically like plugging it into the function machine. Your input is going to be those x values, because remember, input is a synonym for our x. So I'm going to put 1, 2, 3, 4. And then as the word input indicates, I'm going to input this number in where x is in the equation to find the output. So y equals 2 times 1 minus 1. And you end up with 1. Going on to the next one. Y equals 2 times 2 minus 1, which is 3. Y equals 2 times 3 minus 1, which is 5. Y equals 2 times 4 minus 1, and you get 7. So now we have our function table because we need that, and then we're going to answer the question, does the table represent a function? Are any of these inputs, remember those are our girls, are any of these repeated? Hopefully you guys are all thinking or saying no. So this one checks out. There's no cheating. So this is a function. All right, let's take a look at now like a real world situation where you might be doing something with a function table. And this one I probably should have put in here to write a function table because that's what we're doing with this one. It says you're babysitting for a neighbor. You charge $12 per hour and $5 for gas. Your neighbor says they will be gone anywhere from 2 to 4 hours. So we're going to make a function table to figure out how much would I get paid if they were gone for 2 hours, 3 hours, and 4 hours. But first we need to write the equation. Hopefully in here you're recognizing 12 per hour. So this is always our indication, or most of the time our indication, where I'm going to take the amount times the number of hours. So I'm going to have y equals 12x plus we're adding on that cost for the gas. So here's the equation that I'm going to use to make my input-output table. And we're inputting how much will I make if I work for 2 hours, 3 hours, or maybe they're gone for the full 4 hours. How much will I make? Well, let's plug in our input and find our output. 12 times 2 plus 5 is 29. 12 times 3 plus 5 is 41. And 12 times 4 plus 5 is 53. So now we've completed our input table. So now I know no matter how long they're gone, I know how much I would make. All right, let's continue our work with functions. So this one here, remember, when we're working with this functions, this f of x stuff, sometimes we're going to replace this f of this whole piece right here with a number, or sometimes we'll plug in a number for x. So let's see here. So it says, let f of x equal negative 3x plus 2. It says, what is x? So we're trying to find x. So that means this 14 goes in place of the f of x here, because this is what that piece equals. So 14 is going in and replacing that chunk there. So I have 14 equals negative 3x plus 2, and then we're going to work through and solve this equation. Minusing 2 on each side. And then dividing by negative 3. So negative 4 equals x. As you guys are writing this down, I'm just going to talk through another strategy that you can use for this one, if this were a question on the multiple choice test. If you know that you have to find x, but you're not sure how to find x, one of these I should say, is going to be a solution. So if you take negative 44 and plug it in for x, check to see if it equals 14. In this case, it doesn't. Same thing, plug in negative 40 in for x. Then plug in negative 5 1/3 in for x. And then negative 4 in for x. And figure out which one would equal 14. That's a way that you can use guess and check to be able to solve. All right, now we're going to take a look at quite a few problems where we're using order of operations. So in this first one, we want to ask ourselves, are there parentheses? Nope. Any exponents? Nope. Any multiplication or division? Hope you guys are all saying, oh yeah, there is. I see 9 divided by 3. So you have to do that first. And that is 3. Rewriting everything else. And then there isn't any other multiplication or division. So now I add and subtract from left to right. And so you end up with 14 as the simplified answer for this expression. Let's take a look at number 2. Refreshing your memory, remember this fraction bar is a grouping symbol. So I simplify everything on the top, everything on the bottom, and then we're going to divide. So as I look in the numerator, I'm first going to multiply, and we get 32 plus 8, which is 40. So I've simplified everything in the numerator. Let's work our way through the denominator. I need to do exponents first in the denominator. So 10 plus 4 minus 4. And then just for me, because I'm running out of space, but what we would do next is add and subtract from left to right. 10 plus 4 is 14. Minus 4 is 10. And 40 divided by 10, everyone, is 4. So that fraction simplified is 4. Square roots. Remember square roots? They are another grouping symbol. So I need to take care of that grouping symbol first, then continue working through the problem from there. what is the square root of 9? I'm sorry. Hopefully you're all thinking or saying it is 3. Then I continue working in that numerator because again, that's a grouping symbol. So I'm going to multiply. And then add. And hopefully this isn't too low for you guys. But then finally divide. And you end up with 13. Let's look at an order of operations when we have absolute value. So on this one, before you guys do any adding up, I know that's something you guys will usually do, and I forgot to do it on some previous ones. If you see absolute value, always take care of that first. So what is the absolute value of -9? Remember, absolute value makes a number positive, so it becomes a positive 9. Rewriting everything else. Then from here, if you wanted to, you could add up if you would choose to do so. What I'm going to go through and do next, grouping symbols are done. I don't have any exponents. I'm going to multiply or divide from left to right. So I'm going to take care of 9 divided by 3, which is 3. And then careful in this step. A lot of students will do this step incorrectly. Because again, you have to add or subtract from left to right. So whatever you see first. 10 minus 9 is 1 plus 3, which is 4. So be very careful in that second to last step. Make sure you subtract and then you add. Looking at example number 4. Lots of parentheses happening here. So what we have to do is work with the parentheses that are in the center. So we first have to take 9 minus 7, which is 2, times this 2, plus 5, and then plus 26. Notice that these brackets are still here because we haven't simplified everything inside those yet. So I'm going to multiply inside because I have to use order of operations inside. Again, brackets are still here because we haven't done everything inside of them yet. So adding and we get 9. Now those brackets are gone because it's a single digit, or it's a single number I should say, and we've done everything inside of it. And when I add 9 plus 26, we end up with 35. Next thing that we're going to take a look at, and actually the last thing that we're going to review, is the distributive property. Whenever you're working with the distributive property, these are the ones I would for sure add up on. So if we take a look at example number 1, do we see any subtraction at all? We do not. So you're going to distribute the single term, the part that doesn't have the addition or subtraction. So this -10 is going to be distributed to each part inside the larger parentheses. Remember, when you distribute, you multiply. So I want to take -6 times a -10, and that is a positive 60. Be careful. 2 negatives become a positive. Then I have to take this x times x, and when it's x times x, that becomes x squared. Done distributing to that first term, so automatically going to put a plus sign. Distributing to the second part, again multiplying. -10 times 4 is -40, and making sure we get that x. So this answer is perfectly fine. I will tell you guys that on a multiple choice for the MCAs, they will give the answer like this. Both mean the exact same thing, they just don't have this add up piece here, which is fine. but just be able that you can recognize that this would be the multiple choice answer. On number 2, two things I would do here. 1, add up inside the parentheses. And then in front of the parentheses, if there's just a negative sign, remember you have to squeeze in a -1 because we're really distributing a -1 through the parentheses. So -1 times 3x is a -3x plus -1 times a -5 is a +5. And I should be commenting here that these two are not like terms at all, so we don't combine them, and this ends up being our final answer. Same thing this one up here. These two are not like terms. They do both end in an x, but this one's x squared. So these two are not like. That's our final answer. Because in example 3, this one, there are going to be like terms that after we distribute, we're going to need to combine. Adding up first, distributing the 4 through the parentheses. Remember we talked about in class that the end of a parentheses is a big wall. We can never distribute past it. So this becomes 4x plus 4 times 2y is 8y. And we rewrite everything else that comes after it. And then we look to see if there are like terms. I see an x here and an x here. Remember when we talk about combining things, that's when we're adding the two. So I want to think about what is 4 plus a -3x? And that is a 1x. Then plus, taking a positive 8y plus 9y is 17y. And then again, those two are not like terms, so we can't simplify anymore. So 1x plus 17y is a simplified version of this expression. Number 4. Same thing on this one. This one is loaded with some subtraction signs. So we want to make sure we add up first. So when we distribute, remember we distribute the number that comes directly in front of the parentheses. So this -2 is what comes directly in front of the parentheses. So I'm going to distribute that number. This 10 is in front. We're going to deal with that later. Plus -2 times 5 is -10 plus -2 times a -9x. Remember, two negatives become a positive, so it'll be a positive 18x. So we've distributed and gotten rid of the parentheses, but again, look for like terms. These two numbers here, they don't have any variables, they're just constants, so we would add them. But what is 10 plus a -10? It's 0, so they cancel each other out, and all we're left with is 18x. If you had 18x plus 0, it would be fine. But again, multiple choice answer, this is what they would have. Taking a look at number 5. Again, tons of subtraction. Let's add up. And here, there's a minus sign, but there's no number after it. So we have to do plus a -1. So we have to place that 1 in there so that way we know we're distributing a -1. Let's distribute this -4 into the parentheses, into the first parentheses, I should say. negative 12x plus a negative times a negative becomes a positive, so that will be a positive 8. Plus, distributing this negative 1 into the second parentheses, we end up with a negative 7x plus a negative 10. So we've distributed everything on that one. Now again, look for like terms, things that have the same last name. And again, because we're saying we're combining, we are adding them. So negative 12 plus 7 is a negative 19x. Combining the constants, 8 plus a negative 10 is negative 2. So plus a negative 2. Again, this is how most of you guys would write your answer, which is perfectly fine. But again, multiple choice answer would be 19x minus 2. Both are fine. Just be able to recognize this one as a multiple choice answer. Let's look at number 6, and then I'm going to have you guys try a couple of these on your own. On number 6, let's go ahead and add up first, and then distribute. When you're distributing, don't forget you are multiplying. So in this one, I'm taking an x times an x. So I'm going to end up with a negative 10x squared. When you're multiplying, you add the exponent, so it becomes x squared. Plus negative 2x times a negative 7 is a positive 14x. And then plus 12x at the end. And again, combining like terms. The 14 and the 12, those two are like terms because they both end in just an x. This one is x squared, so it's not like the others. It's kind of like, isn't there a Sesame Street? This one is like the, I don't know. Something you guys probably remember. So simplified, we end up with negative 10x squared plus 26x for our simplified expression. All right, these last two for today. I want you guys to try these two on your own. When you're done with both of them, then I'm going to have the sub press play, so that way you guys can see the worked out answers for it. And then after that, with any work time that you guys do end up with, you'll have to have work time to work on the crossword puzzle. So good luck, try these two, and then when you're ready, press play so we can see the answers. So when you're all done on number 7, hopefully you ended up with 24x squared plus 34x. Here you can see what I got when I distributed, and then there were some like terms for us to combine. If you have questions, make sure you guys talk about that one. Number 8, this was probably the hardest one because you had to add up a lot, making sure you put in a negative 1 and adding up again. Here's what you get when you distribute, and then several like terms to combine. So you end up with 3x plus a negative 16. Again, take a look at it, see if you can find any mistakes that you have, talk about it to see if you can help each other out as well. Then, the last thing that I have for you guys with any work time that you guys have, I want you guys to be working on that MCA crossword puzzle. It's due on Friday. So I know I didn't get a chance to talk about it a ton yesterday, just because class time ended really fast. But there is a word list, so you can cross them off as you're using them. And then one side has the clues, and then obviously the crossword puzzles on the other side. Feel free to use Google, your textbook, whatever you need to help you look up the answers. It's basically just to help review a lot of the vocab words that we were learning this year. So work on that tomorrow. Also pass back your practice tests, and then you guys can be able to start working on corrections from there.